All right, hi folks, this is Larry Mussolino. I'm recording a video for Module 7 in Math 181. And this module continues a discussion from Module 6 on really counting the total number of outcomes as part of a decision algorithm. Well, here we want to look at some more advanced counting methods. And this is going to involve something called permutations and combinations. All right, well, let's start off thinking about how to count some items that are in a certain order. So here's a quick example. I'm in the lecture notes from Module 7 here. Here's a quick example. It says, let's say you have 3 items you want to put in order. This example says, imagine you have paintings A, B, and C. Okay, so I have 3 paintings that I want to put in order. Well, how many ways could I put these in some kind of an order on my wall, let's say? Well, of course, I could start out just putting them in order A, B, C. So that's one way I could do it. Or I could swap paintings B and C and make the new order ACB. I could start out and put painting B first, then AC. But then with painting B first, maybe I swap around and now put CA. Well, if you list out all of these possible options, you can see here there's 6 ways to do this. Okay. But we'd like a shortcut on how to do this kind of ordering. So we're going to call these, this method is called factorial to do this kind of calculation. All right, so here's the way to do it. Think about these 3 spots on my wall. Okay. And you might remember this as the multiplication procedure that we talked about last module. Well, I could really pick from 3 ways to populate this first position on my wall. Once I put one of the paintings there, that leaves me 2 paintings to pick from for the middle spot. And then, of course, once I do that, there's only 1 choice for the 3rd spot. And you remember the multiplication principle says multiply these together. But whenever you multiply 3 times 2 times 1 like this, we use a special notation. It's called 3 factorial. So this exclamation point we call factorial. So this is called 3 factorial. So when you have a number factorial, let's say 5 factorial, you start with that number 5 and multiply by all of the numbers, all of the whole numbers below 5 until you get down to 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. If you work this out on your calculator, that would be 120. So if I had 5 paintings that I wanted to hang on my wall, there would be 120 ways to put them in a certain order. Okay, on your calculator, most calculators have a factorial button as a shortcut. Okay, so for example, if you're using, let's say, a TI-84, if you go to the math menu and go over to PRB, so if you're using a TI-84, let's say, click on the math button and then select PRB, and you'll see there's a factorial button on the menu that you can use. Okay, most other calculators have a factorial button as well. Sometimes it's on a menu. You have to figure out what menu it's on, but most scientific calculators will do this calculation for you quickly. All right, well, let me scroll down a little bit here. And here's an example. Let's say there's 5 candidates running for office. How many ways could these 5 names show up on a ballot? Well, the answer is going to be 5 factorial, which is 120, because if you think about it, on the ballot, maybe there's a first name, a second name, third name, fourth name, fifth name in this order. Well, I could pick any of the 5 candidates to put in the top, but once I select one, that means there's 4 ways to fill in the second slot, 3 ways, and so on. And when I multiply these together, I get 5 factorial, 120. All right, well, here's a little bit of a different scenario. What if I have a total number of items, but I only want to pick a subset out of the group. Okay, let's do a quick example here. Let's say, let me scroll down here a little bit. Let's say I wanted to select 3 athletes out of 10 athletes total. So let's say there's 10 athletes competing in a certain Olympic event, and we want to find how many ways can 3 athletes finish first, second, and third. Okay, so I know I'm going to have an athlete here in the first place, another athlete's name here in the second place, and another athlete's name in the third place. But remember, I have 10 athletes total to pick from. Well, there's a formula to handle this kind of scenario, and it's called permutations. A permutation is when you have a total of n items and you want to take r of them at a time as like a subset. So in our example, n is 10 because we have 10 athletes all together. We want to take 3 athletes at a time. So r is 3. Okay. So here's usually the formula that we use to calculate this number. So again, what you have to recognize when using this formula is this is going to be an ordered list, meaning when I have the 3 athletes, they're going to be in some kind of an order because I want the first place name to be, of course, first, then the second place name, then the third place name. Notice this is a specific order here. That's important. All right, and I know n is 10, and I know r is 3. So in order to answer this question, how many ways can I come up with 3 athletes out of 10? We're going to calculate p parenthesis 10 comma 3. So p parenthesis 10 comma 3 means the n number is first and the r number is second. Well, let's work this out. It's going to involve the factorial calculations, and let me show you a little shortcut when you do this. All right, well, according to this formula, p of n comma r is n factorial over n minus r factorial. Okay, so we'll be using this formula quite a bit. Here it is in our example, p of 10 comma 3. Well, our n number is 10, so I'm going to put a 10 factorial on top. And then on the bottom, it's 10 minus 3 factorial. Well, if I was to work this out, this would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over, of course, this denominator is 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. But I'm noticing a lot of this can cancel out. Because on the bottom, I have a 7, which will cancel out with a 7 on top. There's a 6, which will cancel out with a 6 on top. So all of these are going to cancel out. Well, to save a little time, instead of writing all of this out, here's the little shortcut you can use. You say, all right, I know I'm going to have a 7 factorial on the bottom here. Instead of writing out 10 factorial as I just did, I'm going to write it as 10 times 9 times 8 times. Now, instead of writing out here 7 times 6 times 5 times 4 times 3 times 2 times 1, which I can do, but that's really 7 factorial. So I'm just going to leave it in the 7 factorial form to save a little bit of time so I don't have to write that out. Now, I could just cancel out. There's a 7 factorial on the bottom, and a 7 factorial on top. Cancels out. So I'm left with just 10 times 9 times 8, which is 720. So there would be 720 ways for me to organize or list out 3 athletes out of 10 total and put them in the specific order of first, second, and third places. All right, so notice here the order was important in this example. Right, because if I put John, Mary, and Sue in this order, I know John came in first, Mary came in second, Sue came in third. This would be a very different outcome than if I wrote this as Sue, John, Mary. Right? Because now Sue came in first. So order does matter here. Order is important because I'm really specifying who came in first in this race. Now, there are some scenarios where order does not matter. Let's talk about that next. Okay. Folks, by the way, here's a good video to check out from Khan Academy that will show you more examples of working with permutations. All right, well, there's some other scenarios where order is not important. Here's an example. Let's say I have 10 employees and I need to select 3 to be on a committee. Okay. Well, when you select people to be on a committee, they have kind of equal standing and order is not important. So if I was organizing a committee and let's say I had John, Mary, Sue as committee members, well, that's really the same as listing it as Sue, John, Mary. Right? They're just 3 people that are serving on a committee. The order doesn't matter. It's not like Sue is more important than John or something like that. They all have equal standing. So here, order does not matter. Order is not important. All right, well, let's do another example, but now we're going to calculate the combination of n items total, where I take 3 at a time as a subset, let's say. This is called combinations. So combinations is when order is not important. Sometimes we say order does not matter. A committee is a good example, right? Because I'm not concerned about the order of John, Mary, Sue on this committee. All right, well, the formula is a little different. Here it is. So let's work it out. In our example, we want to work out C of 10, 3. I want to know how many ways can I pick 3 employees out of 10 total to serve on a committee. All right, well, remember the N number is first, so that's 10. The R number is second, that's 3. All right, I'm going to plug into this formula. The top is N factorial, so that's 10 factorial. On the bottom, it says put R factorial, so that's 3 factorial in our example. And then N minus R factorial is 10 minus 3 factorial. All right, well, this is going to be 10 factorial over 3 factorial times 7 factorial. Well, let me use that little trick that we just mentioned where it's 10 factorial. I'm going to write as 10 times 9 times 8 times 7 factorial because I'm going to let the 7 factorial cancel out top and bottom. Okay, so I'm going to do that. There's a 7 factorial top, 7 factorial bottom. Let me cancel it out. Here's what I'm left with, 10 times 9 times 8. And on the bottom, 3 factorial is really 3 times 2 times 1. Well, I can just work this out. On the top, it's 720. On the bottom, it's 3. So I think that's 240 ways. So there'd be 240 ways for me to select 3 committee members from 10 possible. Notice this is a much smaller number than 10P3. So remember, when we did P of 10, 3, we got 720. But now we just did C 10, 3, and we got only 240. Well, it makes sense that the number of combinations should be smaller because think about it. John, Mary, Sue is going to be counted the same as Sue, John, Mary for combinations. But for permutations, I would be counting these separately. So it makes sense there should be more permutations versus combinations because there's going to be more ordered listings versus unordered. All right, well, folks, there's a good video here to check out. Again, this is Khan Academy video on combinations, so please take a few minutes to watch that. Remember, these are only like 10-minute videos, so please take a little bit of time to watch those. It'll really help you when you go into the WebAssign homework. So why don't we do some WebAssign examples here? And let me do a couple of WebAssign problems. One other thing I want to mention to you is when you go to work out P of 10, 3, sometimes you might see this written as 10P3 like this. So this is really the same, it's just a little bit of a different notation here. So writing P 10, 3 in parentheses means the N value is 10, the R value is 3. Writing it this way, we put the n number in front and the r number in the back. Putting a p in the middle here means you want permutations. Well, sometimes it's nice to get a calculator to do this for you because this can be a little bit of a, time-consuming calculation. It's not complicated. It's just time-consuming to work out these factorials. So if you go to your calculator, a scientific calculator, or there's many online calculators, a scientific calculator usually has either an NPR button or a NCR button. If you go to a TI-84, for example, go to the math menu, then select PRB. You'll see on the menu both an NPR button and an NCR button. Now, the little tricky thing about using a TI-84 is before you can work out this command, you've got to put the first number into your display. So if you were doing this example, let's say 10P3 on a TI-84, here's what you'd have to do on the display. First, type in the number 10. Then go to the math menu and select NPR. Then it's going to put like a P here. It's actually going to put a little symbol here that says NPR. Then you type in the R number on your, in our example, we type in a 3 here. Then hit enter on your calculator. So it's a little tricky that you got to enter the N number first. In our example, we had to enter a 10. Then you go to the math menu, and then you enter R. So give that a try. There's a lot of videos online that will show you how to do this on a TI-84, or email me if you have a question on that. All right, well, why don't we go do a few WebAssign examples. So let me come here to the Module 7 homework, and let's do a few examples. Let's do this first one. And by the way, folks, please be sure to use this watch it button. Remember, the watch it button is a short video that will explain it. Well, here's what they're giving us on this one: 6 factorial over 4 factorial. Now, of course, I could write this out: 6 times 5 times 4 times 3 times 2 times 1. That's 6 factorial. 4 factorial will be 4 times 3 times 2 times 1. Now I'll just cancel out the 4, 3, 2, 1 on top, cancel out with 4, 3, 2, 1 on the bottom. I end up with the answer 30. A shortcut, though, is to just write the top as 6 times 5 times 4 factorial. Now I just let the 4 factorials cancel out. So that saves me a little bit of time to write it all out. All right, let's go to number 2. Number 2 is just asking me to work out a permutation. So here they're asking me P of 6, 2. And of course, before I do this, I got to remember, what does the permutation formula look like? Let me just mention, in case you forget it, it's in our textbook on page 461. So if you go to page 461, you'll see that it says P of n comma r is equal to n factorial over n minus r factorial. All right, so let's work it out. Remember, the first number here is n, the second number is r. So I'm going to write this as 6 factorial over 6 minus 2 factorial. So this is 6 factorial over 4 factorial. We actually just did this example a second ago. This was 6 times 5 times 4 factorial over 4 factorial. So this turns out to be 30. All right, let's go to number 3. Number 3 is the formula for combinations. Oh, actually, this formula is on page 463. Sorry, page 463 for the permutation formula. Let's go to combinations now. Combinations is on page 464. So let's go to page 464. And what it tells me is, if you want to know the number of combinations, it's n factorial over r factorial n minus r factorial. Okay, well, in our example, n is 11 and r is 4, so I'm going to write this as 11 factorial over 4 factorial, 11 minus 4 factorial. All right, well, that's going to be 11 factorial over 4 factorial, 7 factorial. All right, I'm going to take a little shortcut. 11 factorial, I'm going to write as 11 times 10 times 9 times 8 times 7 factorial. And of course, I'm going to let the 7 factorials cancel out top and bottom. So that 7 factorial on top cancels out the 7 factorial on bottom. Looks like I'm left with 11 times 10 times 9 times 8 over 4 times 3 times 2 times 1. I could just multiply this out on my calculator, but I notice there's a nice little shortcut here because I have a 4 times 2. That'll cancel out with the 8. And then this 3 on the bottom will cancel out with the 9, leaving a 3. So this actually gets rid of the denominator. So it looks like I have 11 times 10 times 3 left. So when I work this out, looks like this is 330. Okay. Remember, if you have a TI-84 or any calculator, any scientific calculator, you probably have these functions available directly on your calculator. All right, let's do a few more examples. All right, let's go to number 5 and 6 quickly. Now, one thing to keep in mind is whenever you see the word ordered list, ordered implies permutations. Unordered means combinations. Remember, permutations, we use the example of first place, second place, third place, right? Combinations, we used the example of committees. All right, well, for number 5, first thing I'm noticing, it says ordered list. And they want to take 3 items out of 10. So I know ordered means permutation. So this is going to be P10, 3. Okay, and we actually worked this example out earlier, but let's list it out. It's 10 factorial over 10 minus 3 factorial. I'm going to write that as 10 factorial over 7 factorial. The top I'm going to write as 10 times 9 times 8 times 7 factorial. And the 7 factorials canceled out, so I'm left with 720 for this one. All right, let me go to number 6. Number 6 says unordered. Well, I know unordered means combinations. And it looks like we have 6 items total, and we want to pick 3 at a time. So this is C, 6, 3. So this is going to be 6 factorial over 3 factorial, 6 minus 3 factorial. Right, remember, I'm just plugging into the formula here that's on page 464. And the formula is C of n comma r is n factorial over r factorial n minus r factorial. All right, let's just work this out. This is 6 factorial over 3 factorial times 3 factorial. All right, I'm going to write this out as 6 times 5 times 4 times 3 factorial, because that will let me cancel out one of the 3 factorials in the denominator. So I'll let this 3 factorial cancel out with that 3 factorial. So it looks like I have 6 times 5 times 4. And then 3 factorial is 3 times 2 times 1. But again, let me cancel. 3 times 2 is 6. That'll cancel out with that 6 on top. So I'm left with just 5 times 4. So 20 ways to select 3 items out of 6 total. Okay. All right, let's do a few more examples here. Again, I'm going to focus more on the examples that don't have a watch it, because the watch it will have a good video to check out. How about if we come here to number 8? And number 8 says, how many three-letter sequences are possible that use these letters, and you can only use them at most once. So that means no repeats. All right, well, let me see how many letters we're talking about. Q-U-A-K-E-S means 6 letters total. And I want to pick 3 letters at a time. Well, notice here, order does matter, right? So I'm going to go ahead and work this out as P6, 3. I'll let you work that out yourself. Okay. Let's go down. Let's go number 10 here for a second. It says a bag contains 3 red, 3 green, 1 lavender, 3 yellows, and 3 orange. Here's the word 1. I think this is a typo. All right. How many possible sets of 4 marbles are there? And notice they're really not saying anything here about order. Order doesn't really matter for this one. And they're also not telling me that, you know, for the 4 marbles, I have to have at least 1 red or at least 1 green. So really all I have to do is count up how many marbles total are there for me to pick from. Well, it looks like there's 3 plus 3 plus 1 plus 3 plus 3. So I think that's 13 altogether. And I want to pick 4 marbles. So this is going to be C13, 4. And again, I'll let you work that out on your calculator or work it out using the formula. All right, let's do, how about number 11 here? It says you're going to make a trip and you have to stop in Thailand, Singapore, Hong Kong, Laos, and Bali. How many possible itineraries are there where the last step is Thailand? All right, well, you know, I'm going to try to set this up using a similar method to that multiplication principle that we talked about. So here are the different stops that I can make. So I'm noticing there's 1, 2, 3, 4, 5 countries altogether that I have to visit. So here are the 5 countries. But it says the last stop has to be Thailand. So I'm going to fill in Thailand here. There's only one way to fill in this last box because the problem says you must visit Thailand as the last stop. All right, so how many ways can I fill in this first box? Well, I know Thailand is already accounted for, so there's really 4 ways to fill in this box. Okay, once I select the country to visit first, let's say it's Bali, that means there's only 3 ways to fill in this box, 2 ways to fill in this box, then there's only going to be 1 way here, and we know Thailand is 1 way. So I'm just going to multiply these together. This is 12 times 2, so this is 24 ways that you can organize this itinerary. All right, let's do a couple more. Let's go number 13. Number 13 is a little more complicated. Let's come here. All right, it says, here are stocks from the Dow Jones stock market listing. These are 10 stocks altogether. You decide to make a portfolio where you want to pick 5 out of the 10. All right, so how many portfolios are possible? All right, now again, notice they're not talking anything about order here. Order doesn't matter. Because when I pick these 5 stocks, you know, if I put stock T, GE, MRK, CAT, KO, let's say these are the 5 stocks I pick. The order doesn't matter here, right? I could reorder this and put KO, MRK, GE, T, CAT like this. This is really the same listing, you know, for this kind of a setup. So order doesn't matter here. So order is not important. I know that means I'm going to use combinations. All right, let's go to part A. Part A says you want to pick 5 out of 10. Well, that's C 10, 5. Okay, if you work that out, you'll end up with the answer 252. So there's 252 ways for you to pick 5 out of these 10 stocks. All right, let's go to part B. How many ways are there to pick stocks that contain VZ and MCD, but neither KO nor XOM? All right, so this one's a little complicated, but let's try to reason it out here. All right, so let's think about this. Now, remember, we have 5 stocks that we're trying to pick, right? So here are the 5 stocks. 1, 2, 3, 4, 5. Okay. All right, now I know 2 of these stocks have to be VZ and MCD. All right, the question is, how many ways can I fill in these other 3 stocks, these 3 selections? Well, I know I'm starting out with 10 stocks altogether, so there's 10 total. But I'm going to subtract 2 out of these because I cannot use KO and XOM. Those are told to be off the list. So that means 8 left. But out of those 8, I'm already using VZ and MCD, right? The problem said you must include those. So that leaves 6 left. So that means I have 6 total to pick from. And I want to pick 3 out of the 6 to fill in these 3 slots here. So I need 6 C, 3. C parentheses 6, 3. Right, because I have 6 stocks left to pick from, and I want to pick 3 out of those stocks to fill in positions A, B, C. And if you work this out on your calculator, you'll get the answer 20. All right, let's go to part C. Part C is a little tricky, but let's talk about that. So part C says, how many of these portfolios contain at least 4 stocks with yields above 3.5%? Okay, so we want at least 4 stocks with yields above 3.5. All right, well, I'm noticing there's actually 5 stocks here that have yields above 3.5%. All right, well, let me try to figure this out. There's really kind of 2 possibilities here. I could end up picking 4 stocks that are above 3.5% yield, or I could pick all 5 stocks, because remember, it said at least 4. At least 4 means I could either end up with 4 stocks above 3.5% yield, or maybe I pick all 5 stocks above 3.5. Either one of these scenarios would meet the requirements of this question. All right, well, for this part, I really want to know how many ways can I pick 5 stocks out of 5 stocks? Remember, I only have 5 stocks to pick from to begin with that are above 3.5% yield. Well, this is C 5, 5. And that's really going to be 1. If you work that out, it's 1. Well, that makes sense. There's only one way to pick 5 stocks out of 5 stocks. You just list out those 5 stocks. The order doesn't matter, so there's really only one way to do that. All right, well, how about picking 4 stocks then, this other scenario? Well, I'm going to have 1 slot here that can be any stock, but then these other 4 must be yields above 3.5%, right? Because I need at least 4 to be above 3.5%. Well, for this part of the question, Let me clear out here a little bit. For this part of the question, I want to be able to pick 4 out of 5. Right? There's 5 stocks to pick from that are above 3.5% yield, and I want 4 out of those 5. All right. And then how many ways could I fill in this first box? Well, if I've taken these 5 stocks, that really leaves me 5 stocks to pick from. So this is going to be C5, 1, because I just want to pick 1 out of the 5 stocks. Okay, so here's really what I'm ending up with. Let me redraw this to be a little clearer here. Here's what I'm ending up with for part C. I want to be able to take care of these 2 scenarios. The first scenario is picking at least 4 stocks. Okay, so I'm working with this scenario. Okay, so what we said is this is going to be the way to pick at least 4 out of the 5. And then this is going to be to account for that 5th stock. Okay, then I've also got to take in the scenario where at least 5 means all 5 of them. So that's C5, 5. All right, well, if you work out C5, 1, that's 5. And if you work out C5, 4, that turns out to also be 5. C5, 5 is 1. So this turns out to be 25 plus 1, 26. So the answer here is 26 portfolios for part C. All right, that's a little tricky. There are some good examples worked out in the textbook that show this kind of a scenario. So please check out the examples listed in section 6.4 of the textbook. All right, let's see what else. Number 16, I think you can see it's ordered sequences, and you want to pick 4 out of 5. So remember, ordered sequence is a permutation, so you're going to be using permutations for number 16. Number 17 is similar to what we just did. Let's go to number 19 for a second here. It says 14 business people have a meeting, and each pair exchange business cards. How many business cards total get exchanged? All right, well, to think about this one, I'm going to set up a scenario similar to the multiplication principle. Okay. Now, imagine you're one of these business people, right? So you're one of the group of 14 going to this meeting. And you want to give your business card to each one of the other people in the meeting. How many business cards would you have to bring with you? Well, does it make sense you would have to bring 13 business cards with you? You're not going to give a card to yourself, but you are going to give a card to the 13 other people in the meeting. So for each one of the 14 people, they're going to be handing out 13 cards. So altogether, 14 times 13 is the number of business cards that get exchanged. Because for each one of the 14 people, they're going to be handing out 13 cards. Remember, you don't give a card to yourself, of course. All right, and this last one, number 20, I think is going to be straightforward. That's just plugging into the permutation formula. So this is going to be 5 factorial over 5 minus 2 factorial. That's 5 factorial over 3 factorial. A reminder of the shortcut. You write the numerator to show the 3 factorial part to let it cancel out the denominator. So this answer is just 5 times 4, which is 20. All right, folks, hope this is helpful as you're getting started in this Module 7 homework. Again, please be sure to look at the lecture notes Please be sure to watch the videos in the lecture notes. Let me know if you have any questions as you're working in WebAssign. Again, please make sure to use the Watch It or the Read It button. Read It will take you into the textbook where that concept is being discussed. Okay, thanks everyone.